I've been scrolling through all these listings for hours now and it's just so frustrating, Like, why can't they list the salary upfront?
I know, right? And there's just way too many websites. How am I supposed to keep track of all of them? Half of these postings don't even match what I'm searching for.
Yes, yeah, it's a waste of time going through all of this irrelevant information. I wish there was an easy way to get recommendations based on our resumes and see the salary information upfront.
Well, I heard that there's a project that may help us computing students. It consists of all the technical jobs that we desire, and they even recommend jobs after you upload your resume.
Really? That sounds like a game changer. We could save so much time and energy.
They also have some salary predictions too, which would totally help us save time.
That's great. Now we don't have to go through so many rounds of interviews just to be disappointed with the compensation in the end.
Wow, that sounds damn good. Let's try out and see if we can get the internship of our dreams.
We understand that searching for a job is extremely difficult in today's economy. Introducing JobLens, a project that makes use of data engineering, data analytics, and machine learning to help you get the job that you deserve. We will elaborate on our project's business use case, then some basic facts about the data, followed by a breakdown of our data pipeline, and then we will conclude our presentation with a walkthrough of our downstream application, which is what you, as our user, will see. The goal of our project is to analyze job market data from leading job portals, which would help our users, which are job seekers, to understand their suitability for various positions and estimate earnings potential. Our team has identified numerous gaps in the current market for job data, have hence designed our project to target these gaps. Firstly, job information is distributed across numerous websites like LinkedIn, Glassdoor, and Indeed. This makes it tedious for users to search for all available jobs, especially with the high volume of new jobs that appear on these job portals each day. Our solution collates jobs listings, removes duplicates, and stores it in a center repository for our user, which would reduce the time spent looking through multiple job portals. With the collated data, our application also provides summary statistics, which allows users to identify and target applications towards the most in-demand job in the current market. Secondly, users currently have to sieve through many job listings and manually identify jobs that they are most suited for, which is extremely time-consuming. By passing through the user's resume, our application is able to identify and present the jobs that best match the user's skill, thereby reducing the amount of time spent for job hunting. This would also ensure that the candidates are matched to the jobs that they have the highest chance of success at. Lastly, many jobs listings do not contain salary data, which is an important consideration when applying for jobs. Our application has therefore introduced a salary prediction feature, which uses existing salary data from comparable job postings to predict potential earnings for jobs without public salary information. This enables users to get a general understanding of a job's financial compensation and allows them to make better informed decisions on whether they want to apply for the job.
The data for our project comes from 3 job portals: Indeed, Glassdoor, and Arzuna. Given the growing popularity of the tech industry and to manage the scope of our project currently focuses on data-related job opportunities based in Singapore. The job fields that we have identified are software engineer, machine learning engineer, data analyst, data architect, business analyst, and data scientist. The job details that we have gathered include job title, company name, salary range, job description, and link to the application. This data will be used as inputs for our downstream applications. The first data source we used is Indeed. For each keyword, information for the latest 70 job listings is scraped from the Indeed website each time the code is run. Using Selenium WebDriver, the specified URL will be entered into the remote Chrome browser session that is created. The keywords that are specified earlier on will then be keyed into the search bar sequentially. After the page loads, the individual job listings will be automatically clicked into, so that information like job title, company name, salary range, application link, job descriptions and requirements can be extracted. These will be done for all the job listings available on the page before proceeding on to the next page. Our second data source is Glassdoor. Similar to Indeed, information for about 70 job listings is scraped from the Glassdoor website for each keyword per run. The scraping is also done using Selenium and BS4 package, and the scraping process is similar. Upon reaching the home page, the script automatically enters the keyword. As each job listing loads, our script interacts with the website by clicking the Show More button to review more details before proceeding to extract them. Throughout the recording, you can observe how job information is extracted from these sources.
We obtain job information from Arjuna's API as well. Its API updates weekly and contains historical job information from various sources. Of course, we use our Python script to read the data into a pandas data frame. However, I would like to show you how we actually make use of the API as seen from their GUI. Since we are only interested in the jobs in Singapore, I will toggle this to SG. Here, I've already entered my credentials, and for example, if I'm only interested in data-related jobs, I will enter data here as a filter. Now, I will run the API to get the response. All this information is cleaned and passed into a data frame that corresponds to the fields in our ER diagram. This is our ER diagram for Arjuna, containing all of the finalized fields.
Our application is built upon the following data pipeline. The data is first retrieved from each data source, namely Indeed, Glassdoor, and Arjuna. We chose to use batch data rather than stream data, given that the window for applying for jobs is typically a few days, and hence, it is not imperative that the most updated job is shown to the user as soon as possible. Given that the extraction is scheduled daily for Glassdoor and Indeed, our users would still have sufficient time to apply for the most recent jobs without the need for real-time data. As for Arjuna, the API documentation states that the API's database is only updated once a week. Since Arjuna doesn't update in real time, there is also no need for streaming. The raw data is then passed into the data processing layer, where a Python script formats the data into our desired format. The data processing approach that we have chosen is ETL as opposed to ELT. This is due to a few reasons. Firstly, the raw data is unstructured and must be cleaned before entering the warehouse to minimize the amount of empty rows and duplicated data that is being stored unnecessarily. This would optimize retrieval in the future and speed up downstream applications as they would not have to be cleaned again. Secondly, since we are not engaging in any real-time data processing and the volume of data is relatively small, there is no need for ELT.
This ETL process is done automatically via Docker and Airflow. Docker was chosen as it would allow us to deploy Airflow consistently across different machines. We chose to use Airflow as it enables us to manage our workflow and distribute tasks across different worker nodes. The overview of the Airflow pipeline is as follows. Our Airflow pipeline first extracts the data from the data source. For Arjuna, we use the API. For Glassdoor and Indeed, we run a web scraper using a Selenium remote WebDriver. The Selenium WebDriver was chosen over other scraping libraries like Scrapy as it enables us to avoid bot detection. To minimize the amount of time spent on scraping, we have decided to run our extraction task in parallel by using two Celery workers, which are monitored using the Celery Flower interface. This has successfully cut down the time to extract the data by 33%. In line with this parallelism of tasks, we also set up a Selenium grid server to enable the parallel execution of Selenium tests across multiple browsers by helping to manage and route test commands. The data is then loaded into a staging environment in BigQuery, where we perform transformations on it to clean the data. The transformations include dropping rows with missing information, dropping duplicates, cleaning text data, standardizing salary range data, and combining data from all sources. We chose to use a staging environment rather than transforming and loading directly to the data warehouse so that we would still have copies of the raw data if the transformation fails. Following transformation, the clean data is then loaded into Google BigQuery, which was chosen as part of our tech stack for the data warehouse. Our downstream applications, which are hosted on Streamlit, query this data warehouse. The data acts as the training data for the salary prediction feature and is the input data for job matching and dashboarding. The final data schema is as follows. Due to aggregation of multiple data sources into one central table, we decided to use a star schema to represent our database structure. The final table serves as the fact table, from which its data is retrieved and used by downstream applications. The Glassdoor, Indeed, and Azuna tables serve as dimension tables, whose columns are easy to modify, granting flexibility to the whole schema. The star schema was chosen as it enables faster data aggregation and simplicity when querying for data due to the reduced number of joins as compared to a snowflake schema.
Our application consists of 3 main features and is hosted on Streamlit. The first feature consists of a dashboard that gives an overview of the current job market. As you can see, we have a pie chart that shows the top 10 most popular roles in the last 7 days. It is mainly data analyst and software engineer roles that are currently the most popular. This bar graph shows the comparison of the minimum and maximum salaries for the top 10 job titles. This line graph shows the number of job postings over time, and this bar graph shows the top industries based on the number of job postings. Next, this is our job recommendation system. There are a few steps we took to make this work. We first upload our resume. The text from the resume is passed by using the PDF Plumber package. Some NLP processing is then performed, including stop word removal and lemmatization. The same is done for job descriptions. The cosine similarity between the uploaded resume and each job description is then calculated. The cosine similarities are then sorted in descending order, and a final ranking is produced where the job with the highest similarity to the resume is ranked as 1. As you can see, the most suitable job for me is ranked 1 here, which is the role Technical Business Analyst at TechBridge Market.
Lastly, this is our salary prediction page. As undergrads who are always searching for jobs, we know that many job listings online often do not contain salary information, and we often go through multiple rounds of interviews. However, some of us end up being extremely dissatisfied with the compensation upon receiving the offer letter. These 3 features here are the input fields for a prospective hunter. By pasting the job type, job field, and job description, our model will be able to output a median predicted salary. First, I will assume that my job is a full-time job. Then, I will want to take on a data analyst role. I'm going to paste a full job description now. This description is processed by an LDA model. The model will assign a numerical value to this description, indicating the topic that most likely matches with this description. This list of topics has already been obtained when we trained the model. As you can see, the expected pay is as shown.
Now, let's evaluate our project. We have made several optimization efforts. Our data pipeline was designed to run tasks in parallel in Airflow, which improved our pipeline efficiency and reduced latency. Overall, it helped shorten the data extraction time by 33%. The use of data batching also helped to simplify our data processing, while resources are provisioned less frequently. In terms of our downstream application, we made use of Streamlit's caching mechanisms to reduce the load on data sources and our prediction model, speeding up the retrieval process. Ultimately, we find that our project acts as a good starting point for job seekers looking into data-related roles based in Singapore and has considerable room for growth and refinement. As for the pipeline, we could have improved it further by adding more salary workers to further distribute the tasks, which would reduce the time spent scraping the data. This is especially important if we decide to increase the scale of the project by scraping more job portals like LinkedIn and JobsDB, as well as scraping more keywords beyond the 6 that were previously identified. With regards to our salary prediction model, it had a relatively poor performance, largely due to underfitting from insufficient data. In future, we could consider acquiring more job data from more sources, which is mainly affected by the efficiency of our pipeline.